Video we explain discovery of proton. Presence of positive charge particle in an atom was first observed by E. Goldstein in 1886. It was based on the concept that atoms are electrically neutral, having same number of positive and negative charge. E. Goldstein performed a series of experiments with a gas discharge tube having a perforated cathode. A new type of rays was produced from the anode which moved toward the cathode. He called these rays as canal rays or anode rays. Properties of canal rays seem to be very dependent on the gas used in the discharge tube. In fact, what he discovered was gas ions, and this will also include hydrogen ions. Goldstein at that time nothing know about its significance. In 1917, Rutherford performed experiment which proved that the hydrogen nucleus is present in other nuclei. Rutherford thought that a hydrogen nucleus or a proton must be the fundamental building block of all nuclei and also possibly a new fundamental particle as well. In this video, we discuss discovery of neutron. In 1933, another particle, neutron, was also discovered, which is known to carry no charge. The mass of a neutron is almost the same as that of a proton. These three particles, electron, proton, and neutron, were given the main name fundamental particle and are shown to be present in all atoms except ordinary hydrogen, which does not have any neutron. Irrespective of the facts that these atoms behave very different from each other. It was, however, also shown that the number of these particles is different in different atoms. After the discovery of these particles, a very important question arises as to how these particles are arranged in a tiny place called atoms. In other words, what is the structure of an atom? Discovery of nucleus. Lord Rutherford in 1911 provided answer to this question. He carried out a remarkable experiment in which he hit a stream of special type of particle to a very thin gold foil. From this experiment, he concluded that an atom has two portions, a tiny central portion which is called as nucleus and a relatively large area surrounding this which is he called extra nucleus portion. It was also discovered that almost all the mass of an atom is concentrated in the nucleus because both the heavy particles proton and neutron are found to be present here. In the nucleus, these two particles are held together by a strong nuclear forces. Bohr atomic model. In 1913, Niels Bohr proposed a model for the hydrogen atom which is called Bohr atomic model. According to this model, the electron can revolve around the nucleus of the atom in specific path called orbits or shell. When the electron is revolving in one of these orbits, its energy is fixed. Also, when the electron is present in the orbit which is closest to the nucleus, its energy is minimum and it is called the ground state of the atom. The orbits that are further away from the nucleus possesses successively greater energy. The electron is not allowed to occupy a space in between the orbits. Since electron present in each shell has a fixed energy, these shells are also named as energy level. The shell which is nearest to the nucleus is called first shell or case shell, and the electron present in it has a fixed value of energy. Similarly, the second shell will also be at a definite distance from the nucleus, which will of course be greater than the first shell, and the energy electron present in it will also possesses greater value of energy. Similarly, electron may also be present in the third or higher shell. Is further subdivided into subshell or orbital. The number of subshell present in a shell is equal to the value of n for that shell. For the first shell, n is equal to 1. It will therefore have only one subshell which is called S subshell. For n is equal to, there will be two subshell S and P. The second shell will therefore have two sets of subshell. The third shell, n is equal to 3, have 3 subshell S, P and D. The fourth shell consists of 4 subshell S, P, D and F. According to modern approach, electrons are like charged clouds whose location around the nucleus cannot be predicted with 100% certainty. All we can say is that there is a certain probability of finding the electron at a certain probable distance from the nucleus. In order to find out the number of electrons which can be accommodated in these extra nuclear shells, the scientists have devised a formula called 2n की power 2 formula, where n can have value 1, 2, 3 and so on. And so They represent the number of shells. Shell have also named as K, L, M, and N and continue. When the value of n is equal to 1, its mean first are the K shell and the maximum number of electrons which can present in this shell is 2. K shell can however have less than 2 electron or it may not have any electron. Similarly, when as n is equal to 2, it means second are L shell and the maximum number of electron accommodate in this shell are 8. For n is equal to 3, M shell it can accommodate 18 electron at the most. This process will go on until the electron present in an atom are finished. The maximum number of electrons which can be accommodated in subshell S, P, D and F are 2, 6, 10 and 14 respectively. In the first shell there are 2 electrons which shall go to the S subshell. In the second shell, 8 electron will be further subdivided into S subshell will have 2 electron and 6 electron will be accommodated in P subshell.